Okay, so let's look at the problems I set for section 4.6. For the first one was to take a bunch of derivatives. So they would take the derivative of ln of 3 plus x, the derivative of ln of x cubed, and the derivative of ln of cosine of x. And so it's all by the chain rule, right? So here we let u equals 3 plus x. So the derivative is 1, and the derivative of ln of u is 1 over u. Multiply them together, and we get 1 on 3 plus x. For here, we've got u equals x cubed. So its derivative is 3x squared. And again, the derivative of ln of u is 1 over u. So here, the derivative is 3x squared divided by u, which is x cubed, and that's just 3 on x. And over here, we let u equals cosine x. So its derivative is minus sine x. And again, derivative of ln of u is 1 over u. Multiply these together, you get minus sine x on cos x, which you might recognize as minus tan x. Okay, in question 6. Okay, we're given that the population grows exponentially. There were, in 1960, there was 2.5 billion. In 1980, there's 3.5 billion. How many are there in 2010? Okay, so the population is going to be P naught. So let's start at 1960. So P naught is 2.5 billion, e to the kt. And so we can use the 1980 data, and that's what happened over 20 years. We can use that to solve k. So that means 3.5 divided by 2.5, and we take ln of it, and if we divide it by 20, then we get our k. And so k turns out to be around 0.0168. And so then to get what happens in 2010, the population is 2.5 e to the k, 0.0168 times time. Now, that's 50 years into the future. You plug that into your calculator, and you get around 5.8, and that's all in billions. Okay, and then finally, question number 8. In question number 8, we're given about carbon 14, so it's carbon dating. So the amount of carbon is e to the kt. That's if we start off with 1 gram or 1 unit of it. So half-life then. So we use this to be able to solve for k. We're told that takes place after 5,730 years. So k equals ln of a half divided by 5,730. And so we want to know how long does it take for 20% to survive. So E, and then we use this K over here, and T is what we're trying to solve for. So T equals ln of 0.2 divided by our K, which is ln of 1/2 divided by 5,730. And if you go ahead and put that in your calculator, it's over 13,000 years. And that's how they actually really do this stuff. Okay, that's the end of the homework.